Hi, in section 10.8 we'll be looking at vectors. So a vector is basically an array that has a magnitude and a direction. So those are the two components of a vector. It's going to have a length or a magnitude and a direction, right? There's an initial point, that's where the vector begins, and a terminal point, that's where the vector ends. The endpoint will have an arrowhead. The standard position is a vector that has an initial point at the origin. That's called the standard position vector. Okay? Given an initial point and a terminal point, you can find the position vector by simply subtracting the x coordinates and the y coordinates. So the vector would be x2 minus x1, comma, y2 minus y1. Okay, so for this first exercise, they're asking us to find the position vector. So it's just a matter of subtracting the x components, x1, y1, x2, y2. So we'll write it as vector v is going to be, we can just call it vector v. We can give it our own name. Usually they call it u or v. And then the notation are these brackets that have kind of like a pointy, kind of like a less than, greater than symbol. So in the first one, the difference of the x's will be 6 minus 2, comma, 4 minus 3. Close your vector off. So the final vector will be 4, comma, 1. Okay, so that is it for that one. That's how you find position vectors. Okay, now we're going to find magnitude and direction of the vector. And for that, they give us two formulas. The first formula will be the magnitude. It's just the square root of a squared plus b squared. And the way you notate the magnitude is with those absolute value symbol bars on the side. And to find the direction, it's the same formula we've been using throughout this chapter. Is tangent theta is equal to the y over the x or the b over the a. And so theta is going to be the inverse tan of b over a. Okay, so now they're going to ask us for this next exercise to find the magnitude and the direction of the vector with initial point and with terminal point. So first thing we need to do is find the position vector, similarly to what we did up above. So we subtract the x coordinates and we subtract the y coordinates first. So let's do that. So first thing is to find the position vector. Okay, and we'll call it v again. All right, subtract the x coordinates, so negative 2 minus negative 8. Careful with those double negatives, comma, negative 5 minus 1. So you should get 6, comma, negative 6. Okay, and it's also important to determine the quadrant that vector, the endpoint of that position vector will lie in. So the endpoint of that vector would be positive, negative, which is quadrant number 4. So that's important so that when we find the direction, we have to make sure that we're in the correct quadrant. Okay, so that's quadrant 4. Okay, so that is the position vector. Let's highlight that. Okay, now we want to find the magnitude. So remember, the magnitude is indicated or notated by the absolute values of the square root of a squared plus b squared of the position vector. So that would be 6 squared plus negative 6 squared, which is 36 plus 36, which is 72. Well, that's the same thing as, let's get a decimal. For these vectors problems, usually you want a decimal. So if you type that into your calculator, you should get about approximately 8.49. Let's just round to 2 decimal places for that. So that is the magnitude of the vector, or the length. Now, finally, we can find the direction. So this is the magnitude, and the last thing is the direction. Okay. Okay, so for the direction, we're going to use the formula tangent of theta is equal to b over a, which is negative 6 over 6, which is negative 1. So if you look in the fourth quadrant, and for these angles, we're going to go ahead and use degrees. Degrees is fine for vectors. You could use radians if you like, but I think I'm going to go with degrees for this. So if you look at the fourth quadrant, the angle that has a tangent value of -1 turns out to be 315 degrees. So that's the direction of the vector. All right, we are done with that problem. So let's move on to the next page. Okay, so this page talks about vector operations such as additions, subtractions, and scalar multiplications. So additions, subtraction, and scalar multiplication with vectors. So the addition is pretty straightforward. All you're really doing is just adding the x components or the horizontal components, and then you're going to add the vertical components, the c plus the b. I'm sorry, the b plus the d. And then subtraction works similarly. You subtract the horizontal components, and then you're going to subtract the vertical components. So b minus d. And for scalar multiplication, you simply just multiply by the constant. In this case, they're calling the constant k. So you multiply the horizontal component by k and the vertical component by k. And they show us a geometric representation of addition and subtraction of two vectors. As you can see, vector u plus vector v is the diagonal. You draw the v vector at the endpoint of the u vector. Okay, and for the subtraction, you'll go u, and then minus v goes in the opposite direction. So it turns out to be the opposite diagonal. Okay, so that's just a geometric representation of addition and subtraction of vectors. For this following exercise, they want us to find the scalar multiplication. They're multiplying vector u by the scalar 3, and then they're adding that to the vector v times the scalar of 2. So let's first find 3u first. So we're multiplying vector u by the scalar 3. So that just means 3 times 3, which is 9, comma, 3 times -2, which is -6. And then we go ahead and find 2v. Multiplying the vector v by a scalar of 2 will give us -2 times, comma 8. So I just multiplied this one by 2 and this one by 2. And that's how I got that. And now we're going to add those two vectors together. So when you add them, you should end up with 3u plus 2v. You simply add the horizontal components together, 9 plus -2, and then you add the vertical components together, -6 plus 8. So our final result should be vector 7, comma 2. That is the final answer for that. Okay, so we are done there. Okay, let's move on. Let's see what we have down below. So then they're going to talk about unit vectors. A unit vector is a vector with the magnitude of 1. That's why they call it a unit vector, because a unit is 1. We often find the unit vector in the same direction as a given non-zero vector. Okay, so here's a formula to find a unit vector given any vector v. So if you're given any vector v, you can always find the unit vector, which is the vector that has the same direction with length 1, by simply taking the vector and dividing it by the absolute value or the magnitude of v. Okay, and then you multiply, that becomes your scalar, and you multiply that times the vector v. Okay, so let's apply that formula on the next page. They do give us a different notation, which is called standard unit vectors. So the standard unit vectors are 1, 0 for I, and for j, the standard unit vector would be 0, 1. So those are called standard unit vectors. Okay, so you could represent a vector with the I and j notation. So instead of representing the vector in this notation, you can represent it in the I, the ij notation by just simply taking the horizontal component times I and the vertical component times b. So it's just a different way to write the same vector. Okay, let's find a unit vector in the same direction as -5, 12. All right, so first thing we need to find is the magnitude. So here's the magnitude of v. Recall, it's just the square root of a squared plus b squared, which is going to be the square root of 169, which is 13. So the magnitude of vector v is 13. Okay, now we can apply the formula. So for unit vector, the formula, if you recall from the previous page, is the vector v divided by its magnitude. All right, and that's pretty much it. So vector v divided by the magnitude is going to be -5 is vector v, the horizontal component, divided by its magnitude is 13, comma, the vertical component is 12, divided by the magnitude, and that is the unit vector. So this vector has the same direction as v, and it's got a magnitude of 1. You can verify that if you wanted to by applying this formula to this vector, and you will see you should get 1. Okay, let's see what we have down below. The last thing we're looking at is the dot product. Okay, so the dot product of two vectors is a scalar. It's a real number, not a vector. The dot product is just a real number. And it's useful to find the angle between two vectors. So if you have two vectors that cross, you can find the angle between them. Okay, so first thing is first, the definition of the dot product would be u times v is equal to, you multiply the horizontal components together plus the product of the vertical components, which is b times d. All right, so in other words, you're just doing a times c plus b times d. That's the dot product. Once you have the dot product, then you can find the angle between two vectors. So for example, if you have two vectors, you can find this angle by applying this formula. Okay, so let's find the angle between these two vectors, u and v. All right, so first thing we should do is let's find the dot product. So dot product would be the first step. All right, so u times v is going to be, you multiply the, it's not a vector, so I've already made a mistake there. I'm not supposed to get a vector, I'm supposed to get a scalar, a real number. So -3 times 5 plus 4 times 12. If you do that, you should get 33. Okay, so that is the dot product. It's a real number. All right, now let's find the magnitude. So the magnitude is going to look like this. We have to find the magnitude of both vectors, the u and the v. So the u is going to be the square root of -3 squared plus 4 squared, which is going to be 25. Square root of 25 is 5. So we got the magnitude of the u. Now let's find the magnitude of the v. It's going to be 5 squared plus 12 squared, which is the square root of 169, which is 13. Okay, once you have that, the magnitude and the dot product, now we're ready to apply the formula up above, which is cosine theta equals the dot product divided by the magnitudes of both vectors. So we have cosine of theta equals 33 divided by 5 times 13. That turns out to be 33 over 65. And now we can use the inverse cos to find our angle. Theta is equal to the inverse of cosine of 33 over 65. Once again, it's better to just use degrees for these type of vector problems. That's what I've noticed. So theta is equal to, if you make sure that your calculator is in degree mode, you should get 59.5 degrees. Okay, and that is the final answer. That is the angle. That's the angle between those two vectors. So that is the final answer. And that completes this section.